Reciprocal of cos means we change it as secant. Reciprocal of sine means we can change it as cosecant. So because of that reason here we have RHS secant and cosecant as RHS, whereas LHS we have tan in terms of tan and cot.
Okay.
So since LHS is there in terms of tan and cot Hasmi, we will change everything to first sine and cos Hasmi. Because since tan and cot we can write it as in terms of sine and cos easily, we'll change it everything to sine and cos.
Okay.
Because
Including
we
the
can write
RHS?
even tan and cot in terms of secant and cosecant also, but that will again we have to remember some extra things, confusing.
Sir, including
Okay.
RHS?
No, RHS we need to bring. Consider LHS. We'll consider LHS as me. That is, so we'll not write directly tan and cot in terms of secant and cosecant as. We can even write like that also, but it will you have to remember some extra things which will confuse us.
Okay.
So since we know already tan as sine by cos and cot as cos by sine, we'll replace like with that with tan and cot with sine by cos and cot with cos by sine.
Okay.
Then we'll simplify it, Hasni. Somewhere in the last, we get like 1 plus 1 by cos into 1 by sine like that. Then we can replace it as 1 plus secant theta into cosecant theta like that.
Okay.
So we should understand that even though we are writing in terms of sine and cos, later the answer gets converted to secant and cosecant because the reason is reciprocal of sine is cosecant, reciprocal of cos is secant. So anyways,
Oh.
we are writing the steps in terms of sine and cos. Okay, Hasni?
Okay.
Yes. So now what I'm doing is Hasni sine theta, tan theta, I'm writing it as this Hasni. I think you might have written that step now, Hasni.
Yes, sir. I'm writing it.
Yes, Hasni. Consider LHS. Sine theta by cos theta 1 minus cos theta by sine theta. Correct, Hasni?
Yes, sir.
Converting to sine cos. So plus Hasni cot theta is cos theta by sine theta Hasni by 1 minus correct Hasni?
Yes.
Any doubt Hasni? Correct? You're in mute. Hasni, you're in mute Hasni. You're in mute Hasni. Without Hasni.
Oh, I was saying I have no doubt.
So Hasni, now numerator we cannot do anything because already this is single fraction here.
Yes.
So denominators we can do with some simplification. What simplification Hasni? Applying LCM because this is 1 means 1 by 1.
Yes.
So now Hasni
Yes.
can do LCM. So LCM is how much Hasni for this part?
Sine theta.
Yes, Hasni. So into sin theta we have to do, which will become finally if I directly club it Hasni, I think can I write directly like this Hasni? I just one step extra instead of writing, I directly wrote it. Because if you, anyways, this should be written as sin theta by sin theta now.
Yes.
So when we club it again, it will become sin theta minus cos theta by sin theta. Correct, Hasni?
Yes.
Plus Hasni. numerator is cos theta by sin theta by, it will become cos theta by cos theta. Now, Hasni,
Yes, sir. Cos theta minus sin theta, yes, sir.
yes, Hasni. Any doubt, Hasni?
No doubt, sir.
So cos theta minus, because the reason is that denominator cos now, Hasni. We have to write cos theta by cos theta minus sin theta by cos.
Okay.
So cos theta minus sin theta by cos theta, correct, Hasni?
Yes, sir.
So now, Hasni, we can see these are two fractions. Fraction over fraction means the denominator fraction. This is the main denominator now. This line. Like this line will separate the main denominator. This part will be the main. Okay, Hasni?
Okay, sir.
Means this bigger line will separate the numerator fraction and the denominator fraction. Means we have two fractions, fraction over fraction. So the denominator fraction gets reciprocated.
Okay.
So now, Hasni.
Yes, sir.
So what I have to write? Can you tell Hasni next step?
Yes.
So
Then you have to
what we
write
can,
side. Could you repeat?
yes, Hasni, I can.
So sin theta by cos theta into sin theta by sin minus cos theta plus cos theta into cos theta by sin theta into yes, into cos theta minus sin theta.
Hasni, once you'll write it and we'll send the picture. Hasni, this step one means denominator fraction
Okay.
gets reciprocated. Means we'll get like sin theta. So can I directly write, Hasni? This will go and multiply with this, and these two will get multiplied.
Yes, sir.
So can I write directly like sin square theta by, if I multiply them, Hasni, sin square theta by cos theta into bracket open sin theta minus cos theta. I just wrote an direct step, Hasni. Whatever step you just now send now, Hasni, that the numerators and denominators, if we multiply, we'll get this one.
Yes, sir.
So I wrote the sin theta minus cos theta in the bracket because it's a binomial, like two terms, not binomial kind of. It's a two terms, no? And this separated by minus. So if you
Yes.
multiply this cos, we have to multiply with both of them.
Okay.
So that's why we kept it in bracket. Hasni. If you don't keep in bracket, then again we may multiply our cos with only sin.
Okay.
So as of now, we'll keep it in the bracket. Hasni, now in plus is there in between. Similarly, here also Hasni, these two will get multiplied, cos and cos,
Okay.
and these two will get multiplied. Hasni. So cos square theta by, what will you get, Hasni? Sin theta into cos theta minus sin theta. Okay, Hasni?
Okay, sir.
Because this part will get that only now.
Yes, sir.
Need out, Hasni.
No doubt, sir.
So now, Hasni, this is the important step for this sum, Hasni.
Okay.
So if you observe the denominators, Hasni, denominators, this sin theta minus cos theta, here cos theta minus sin theta, they're actually like, if you see, Hasni, 2 if you multiply with minus, like if 2 and minus 2 is there, Hasni, just the common thing for them is minus 1, Hasni.
Yes, sir.
Like if suppose we have a step like this, Hasni, 2 plus minus 2 minus 1, if I take common, minus 1 into minus 1 minus, sorry, minus 1 into minus 2 is plus 2. Okay, minus means I don't want to confuse you, Hasni, but simply if you multiply anything with minus, like for example, Hasni, a minus b, I can write it as minus of b minus a, Hasni. If you want, you can multiply it and check it, we'll get this one.
Okay.
Means minus of, if I open this bracket, Hasni, minus b, minus of minus a is plus a, so a minus b. So now, Hasni,
Okay. Yes, sir.
so like that denominator, if you observe sin theta minus cos theta, here cos theta minus sin theta is, we'll make it look same, Hasni, both of them.
Okay.
So we'll make it look both of them sin theta minus cos theta.
First.
So this is already sin theta minus cos theta. Just if I take minus 1 common from this part, if I take minus 1 common, Hasni, to get back the original thing without change, we have to write minus cos theta plus sin theta inside. Means if I take, actually cos theta and sin theta, there is nothing common, Hasni,
Okay.
for both of them to take. But since we require here, one is a common factor for everything.
Yes, sir.
So since I want to make it look like sin theta minus cos theta minus sin theta, I'm writing it as minus 1 into sin, minus 1 into sin theta minus,
Cos theta.
once multiplied with minus 1, Hasni, what we'll get, we'll get back cos theta. We didn't change anything.
Yes, sir. We get it as minus sin theta plus cos theta.
Yes, Hasni, which is nothing but minus sin theta plus cos theta is nothing but cos theta minus sin theta.
Yes, sir.
Okay, Hasni.
Okay.
So this is the important step, Hasni, for this summer. So what I am doing is, Hasni, now I am taking that minus 1 common in the denominator, Hasni, for the second part, and I'll make it look like sin minus cos. Okay, Hasni.
Okay.
So now what I will do is, Hasni, it will be like, I can take, I'll write this step as it is, Hasni. Sin square theta, I'll do it here, Hasni, this side. From here, just place it. Okay, Hasni.
Okay.
So now I'm writing it like this, Hasni. Sin square theta minus sin square theta by cos theta into sin theta minus cos theta plus cos square theta by sin theta into cos theta minus sin theta. Okay, Hasni.
Okay.
That step only I rewrote it, Hasni. Now what I'll do is I'll take minus common in the denominator. So Hasni, that minus common in the denominator for this means it's nothing but this fraction, because that minus 1, whatever we are taking common, will come and multiply with sin theta only beside. Because I
Yes.
cannot write a different sign here, minus 1 like that. Because it's
Okay.
multiplication between sin theta and this bracket, no?
Yes,
So
sir.
minus 1, whatever I am taking common, should also be multiplied with sin theta only. If I write
Yes.
like this, no, what will become? Again, it's subtraction.
Yes.
Means whatever minus 1 I am taking common, I have to multiply with sin. Then only again
Okay.
it is multiplication between sin and cos theta minus sin theta.
Okay.
So now what I'm doing it is Hasni sin square theta by. So shall I direct, since you understood Hasni, shall I directly write here minus sin theta into, means 1 I am not writing because 1 into sin theta means minus 1
Okay.
into sin theta minus sin theta.
Okay.
So now I'll write like this Hasni, sin square theta by cos theta into sin theta minus cos theta plus cos square theta by minus sin theta Hasni. Indirect. Minus where come means here, from here I took common Hasni. And directly I wrote it as sin minus cos as means a minus b is equal to minus of b minus a direct, like that.
Yes.
Means actually I should write it as minus cos theta plus sin theta. No, Hasni here.
Yes.
When I take minus common, minus cos theta plus sin theta is nothing but sin theta minus cos theta.
Cos theta.
Yes or no, Hasni?
Yes, sir.
Okay, Hasni. So now sin square theta by, now Hasni, this minus is nothing but indirectly for this fraction only, no?
Yes, sir.
So whenever we have, like for example, 5 by minus 3 Hasni, this minus applies for the numerator only. Finally, we'll write it as minus 5 by 3. So now Hasni, denominator will not write minus.
Yes, sir.
So now Hasni,
Yes, sir.
so now indirectly this minus is for the numerator. In between plus is there, plus of minus.
Plus of minus minus.
So finally this minus, because of that minus, whatever the addition between the two fractions becomes subtraction now. So directly I'm writing like this as now. Sin square theta by cos theta into sin theta minus cos theta minus cos square theta by sin theta into. So where from this this minus only came here has.
Okay.
Actually, this minus goes to the numerator, but plus of minus finally minus.
Okay.
So what is the use of all this? You may get a doubt. Because ask me, if you take direct LCM for this, we would have taken direct LCM here itself without doing all this ask.
Yes.
But you can imagine when you have to multiply this full part here and this full part here, then addition, then denominators you need to multiply. It will be very confusing. Yes or no, Has?
Yes, sir.
So because of that reason, if you understand, if you just can get the idea that sin theta minus cos theta is only there indirectly in the denominator of the other part. What is the advantage is Hasni? We can just take this, we can make it look like sin theta minus cos theta by these steps Hasni.
Okay.
Now here also we will not do direct like this into this like this. Why? Because Hasni, we have a common part in the denominator. Like for example, Hasni, if we have 10, 1 by 10 minus 1 by 5, LCM will become 10 here.
Yes, sir.
So means what 10 has 5 into 2. So
Yes.
5 in both of them it is there. We are not taking 2 times. We are taking only 1 time, 5 into 2.
Yes.
Okay, Hasni?
Okay.
So denominator sin theta minus cos theta is there 2 times. So we should take only 1 time.
Okay.
So to avoid that confusion taking 1 time, what I will do is Hasni, now I'll take common. Numerator nothing is common means 1 has.
Okay.
Denominators, both the denominators have sin theta minus cos theta. No?
Yes.
So to avoid that confusion of LCM here, Hasni, that sin theta minus cos theta part should be taken only 1 time. I am taking common Hasni. Leftover parts I am writing inside the denominator. First fraction has sin square theta, and denominator we have means sin theta minus cos theta. I took common Hasni in the denominator. And
Okay.
numerator nothing is common means 1. Now minus I have what I will write here as in the second fraction. Can you tell?
Cos square theta
Yes, Hasni.
by sin theta.
Yes, Hasni. Because sin theta minus cos theta is taken common Hasni.
Okay.
Yes or no, Hasni?
Yes, sir.
Means both these parts sin theta cos minus cos theta that we took it common outside. Numerator also we should take them. So numerator nothing is there common, so 1 we took.
Okay.
So numerator part as it is we wrote, cos square theta as it is we wrote. Denominator's leftover parts we wrote it here.
Okay.
So asking from here, normal LCM inside the bracket has. Means this part will repeat it as it is in the next step. This part will not change anything. Okay, Ashley?
Okay, sir.
Here this sin square theta will multiply with sin theta and cos square theta will multiply with cos theta. And denominator sin theta into
Cos theta.
cos theta. So like that we will simplify it as. So once then next here you will get after doing that Hasni, numerator sin square theta into sin theta, sin cube theta will get Hasni. Cos square theta into cos theta, cos cube theta. The numerator looks like sin cube theta minus cos cube theta Hasni. Numerator looks like
Okay.
sin cube theta minus cos cube theta, which means a cube minus b cube.
Okay.
So once you will try to recollect the a cube minus b cube formula from polynomials chapter of class 9 Hasni. And that we should apply it here. Once you will try it as homework, ask me that part by learning that formula
Okay.
is asked me. Means how we will apply a minus b whole square or a plus b whole square if we get in the middle of the sum like that. Here a cube minus b cube, sin cube minus sin cube theta minus cos cube theta, a cube minus b cube formula we have to apply it as.
Okay.
Yes. Again we'll finish it in the tomorrow's class once you get try it.
Okay.
Yes. Bye.
Bye.